We'll take certain multiple choice questions on data structure. The source and courtesy is from this website. Let's start. Which of the following is or are the levels of implementation of data structure? So these are 4 options for you. Can you guess the answer? The answer is D. All the levels, abstraction level or abstract level, application level and implementation level. These are the levels of implementation of data structure. Next is a binary search tree whose left subtree and right subtree differ in height by at most 1 is called as. Can you guess the answer? Left subtree and right subtree differ by height at most 1. That is -1 or +1. Okay. The answer here is the avial tree. Because the property of avial tree is that the difference of height of left subtree and right subtree can only be -1, +1 or say 0. +1 or say 0. If it is more than that or beyond these values, then the avial tree needs to be balanced. So this type of binary tree, because this is also binary tree, this type of unbalanced binary tree can be avoided in the avial tree. So you have a nice and balanced the actual tree which you want as a binary tree. So avial tree is essentially a binary tree only with this property. Next is dash level is where the model becomes compatible executable code. This is the level is where the model becomes compatible with the executable code. The answer is implementation level. At this level, this happens. Stack is also known as, this is the data structure stack. What happens here is the last one which is placed is the first one to be removed. So last in, first out, this is the answer. These are 4 options, the answer will be A. Now next is, which of the following is true about the characteristics of abstract data type? Now these are the options for you, give me the correct answer. Please tell me what is abstract data type, what are the characteristics of abstract data type or ADT as we know it, abstract data type. For example, stacks, queues, these are abstract data types. Why they are called abstract data type but not data types? The answer is, these are 2 assertions, you have to tell which of this is true and false, etc. So the answer would be C. It exports a type, any type, that is the basic data type, and it exports a set of operations. So set of operation, actually abstract data type is the mathematical model of storing or organizing the data with certain set of operations which are defined on it. So we don't talk about the actual implementation. That is why we say it is abstract. It is abstract, but you can implement it in any way, but it should be like this, that these set of operations can be applied, and these are the only operations that can be applied. Next is, dash is not the component of data structure. What is not the component of data structure? These are the options for you. Can you answer? Is not the component of data structure, you have to tell. And the answer is none of the above. That means operations, storage structures, algorithm, they all are the component of data structure. Next is, which of the following is not the part of ADT description? ADT description. Which of these are not the part of abstract data type description? So, give me the answer. Which of the following is not the part of ADT description? The answer is, can you guess the answer? Answer is, so the answer is actually both of the above. C. Which of the following is not the part of ADT description? The answer is, let me tell you this, the answer is not this. Why I am taking both of the above, which is not the part of ADT, it should be D, none of the above. Because what I am trying to tell you is, data and operation, they both are part of ADT description. ADT is actually the user view. Why it is abstract data type? Because it doesn't tell you what is inside, what is happening inside. The user says, okay, I want to add or remove at certain from one end and the other end. This is what he is aware. So this is not the implementer view. So data and operations, they both are the DD description. So we'll take the answer as D. Next is inserting an item into the stack when stack is not full is called dash operation, and the deletion of an item from the stack when stack is not empty is called dash operation. What is this? Give me the answer. Can you answer? Inserting an item into the stack when stack is not full. This is push, of course push, and removing or deleting an item from the stack when stack is not empty is called as the pop operation. So we'll go with A. Next is dash is a pile in which items are added at one end and removed from another. This is the data, more precisely the abstract data structure or the abstract data type. So what is this data structure? So it is actually a data structure. So this is Q. The answer will be Q. 9 will be B. 10th is dash is very useful in such situation where data have to be stored and then retrieved in reverse order. Stored and removed in the reverse order. So what would be your answer? The answer is of course stack, as we have seen that when you can take an example of recursive function. So when you place the values here, the latest value can be taken back. So this is reverse order. Next is which data structure allows deleting data item from and inserting at rear. Which data structure allows deleting data item from and inserting at rear from. So the answer is, let me change the question. Which data structure allows deleting data item from front and inserting at rear? What can be the answer? The answer is of course the Qs. Okay. Then next is which of the following data structure can't store the non-homogeneous data elements? Non-homogeneous, that means homogeneous means say we are having say integer numbers. All integers, these are homogeneous. All characters are homogeneous. But you want to place integer here and character also. This is non-homogeneous. So the answer here is arrays. Arrays can only have homogeneous data element. So we'll go with A. Next is a dash is a data structure that organizes data similar to a line in the supermarket. Line, the supermarket, where the first one in the line is the first one which comes out. And the answer is, what can be the answer? The answer is Q linked list. If this is represented by a linked list, then it can be Q linked list. So we go with the answer A. Which of the following is non-linear data structure? See, data structure can be of two types: linear and non-linear. Linear means they are sequential, means you can search them, traverse them one by one sequentially. While the these are the say stacks and list, these are the linear data structure, and strings also. For example, we talk about graph and trees. They are not linear. Why? Tree structure is like this. If from one node you can go to only another node, this is linear node, linear traversal or linear data structure. But in tree, from one node you can go to two different nodes. It is possible. In graph also, from one point you can go to 2 point. This. So if this type of structure is there, we call it as non-linear. So the answer would be here trees. D will be correct. Herder node is used as a sentinel. Then where? Sentinel means say in C you have seen that in your string you last put it as /0. So this can be assumed to be as /0 is a sentinel type of thing. So you put something for your convenience, your own character or something which is called as sentinel. So answer here is herder node is used as a sentinel in the binary tree. Next is which data structure is used in breadth first search of a graph to hold nodes. Breadth first search. There are two types of searching in graph. One is breadth first search, BFS, and the other is depth first search. So these are two types of searching. So which data structure is used in breadth first search of a graph to hold nodes? The answer is Q. We use Q to hold it. Next is identify the data structure which allows deletion at both ends of the list but insertion at only one end. what this question is asking about is you want a data structure which allows deletion at both end you can delete, but insertion can only be at one end. So what can be your answer? The answer is input restricted DQ. Input restricted DQ. Next is, which of the following data structure is non-linear type? As I suggested, what is linear and non-linear? Non-linear will you be able to go with graph after my discussion? Yes, the answer is graph only. Which of the following data structure is linear type? Can you answer linear type? In these three, graph, trees and binary tree, they all are non-linear. So answer would be D, stack. Next is to represent hierarchical relationship between elements. Which data structure is used? Hierarchical means this kind of data structure. What can it be? The answer would be tree, of course, as it represents. The first is a directed graph is dash if there is a path from each vertex to each other vertex in the digraph. Digraph is actually directed graph only. So if you have path from each vertex to each other vertex, then this is known as, these are the options. This directed graph is known as what? This is known as B, strongly connected. This is the answer for you. Next is in the dash traversal, we process all the vertex descendants before we move to an adjacent vertex. What type of traversal is this in graph? You know, in graph we have two type of main traversals, depth first and breadth first. And this sentence is stating for the first one, depth first. Next is state true or false. These are three sentences. You have to tell that which is true, which is false from these options, and please read them very carefully and tell me the answer. Let us see what can be the answer. By first glimpse, the answer is seen to be B. So let us see whether this B is correct or not. First is true. That is, network is a graph that has weights or costs associated with it. So this is true. An undirected graph which contains no cycle is called a forest. Undirected graph with no cycles is called a forest. Is it so? Can you take it like this? Let us leave it for now. Let us take the second one. Next one is, a graph is said to be complete if there is no edge between every pair of vertices. Now this is false. Okay. So first is true and the last is false. And the only option we know here is true and false. So we take B as the correct answer. So we assume this to be true. This is how we do it. So the options left for us would be like this only. Match the following. Completeness with what? Time complexity, space complexity. What will be the answer? Please read them very carefully. Try to match them. The answer in the first glimpse seems to be the C, the third option. So let us see. First, the completeness. It is the strategy guaranteed to find the solution when there is one. So this is completeness. This is correct. Then B is one, that is time complexity. How long? Yes, how long does it take to find a solution? This is time complexity. Space complexity is about the memory. So C is how much memory you need to perform this. This is correct. So we go with this answer. C. Next is the number of comparisons done by a sequential search is. How many comparisons? Can you guess the answer? The answer is B, n plus 1 by 2. You can just easily find that if we have 1 to n number and we have to search for the corresponding each value, and there can be, you can find it at first position, you can find it at nth position, you can find it at certain other position. So it will be nothing but n plus 1 first position, n position, and that will be n plus 1 by 2. Okay. So the answer is this. Next is in dash, search start at the beginning of the list and check every element in the list. So it has to check every element and it always start with the first. So is it linear search? The answer is correct. It is linear search. We go with A. Next question is, we have to say true and false for these two options. And please read them very carefully and try to answer. At the first glimpse, the answer seems to be the fourth option, D. Let us see. Binary search is used for searching in a sorted array. This is This is correct. Because you need the array to be sorted. Then only you can apply the binary search. Second is, the time complexity of binary search is order of log n. Is it true or false? Is it true or false? This is true. It is order of log n only. Okay. Every time you break n by 2, n by 2 square, n by 2k. So when this n by 2k or 2k equal to n, there will be only one item left. So n is equal to 2 to the power k. Take log n, and that will be only k. K will be order of log n. So this is correct. Which of the following is not the internal sort? Internal sort. They are internal sort also. They are external sort also. Which of this is not the internal sort? Please answer this. Not an internal sort or in place sort. The answer is merge sort. It is not an internal sort. While insertion sort, dual sort, heap sort, they all are internal sort. Next is state true and false for this. Please read these two carefully and try to answer which is the correct answer. The answer here is, at first go, A seems to be correct. Let us see. An undirected graph which contains no cycle is called the forest. We have already seen this. That is true. And a graph is said to be complete if there is an edge between every pair of vertices. This is also true. So A is correct. Next is, a graph is said to be dash if the vertices can be split into two set of vertices, V1 and V2, V1 and V2, and such that there are no edges between two vertices of V1 or between two vertices of V1 and two vertices of V2. So what can be the answer? These are the options for you. The answer is bipartite. Bipartite, this is the correct answer. The graph is said to be bipartite. Bipartite if the vertices can be split into two set V1 and V2 such that there are no edges between two vertices V1 or two vertices of V2. Next is, in a queue, the initial value of front pointer F, pointer R should be dash and dash. Okay. In a queue, the initial value of front pointer, that is the front pointer, or of this pointer, should be dash and dash. What these values are? Front and rear. Sorry, this is rear pointer. Rear pointer. So front and rear. And rear. In a queue, what happens that there is no value. Right now it is in initial, because this is asking about the initial values of front and rear. So if there is no value, front needs to be -1, okay, or front needs to be 0, and rear should be -1, okay. So what happens when, because front remains front always, but rear is not there. So rear, if it is increased, then if we have one value, so rear will become 1. If it is -1, it will become 0. So the 0 position is correct, but front will always point to 0. So this will be 0 and -1. Okay, you got the point? Let me tell you again. See, if this is the initial value, there is no value. So front will be the 0th value. Front will have a 0 value. Why? Because front is the front. There is no value, but still front is pointing to the first one. So that is 0. But rear is pointing where? Because there is no rear. So rear will be -1, because once we insert a number, say x, front will be 0 only, means 0 index, but rear will become -1 plus 0, that is 0. So rear will point to this. So front and rear will be pointing to these values, means only one value. And then we place y, so front will remain same, rear will become 1. So the answer would be 0 and -1. In a circular queue, the value of r will be, what is the value of r? And this is given by, you know that we use modulo here. So this is given by, what could be the answer? The answer is C. R plus 1 modulo Q size. This is the answer. Now, which of the following statement is true? These are options for you. Please read them very carefully and tell me which of the following statement is true. Did you find the answer as C? Did you find it C? Let us see. Using singly linked list and circular list, it is not possible to traverse the list backward. Okay, it is absolutely correct. It is only possible when we use DQ. That is, not DQ. DQ is another form. Or when you have linked list, until unless you have a doubly linked list, you cannot go backwards. Singly linked list and circular linked list or circular list, you can only traverse in one direction, not the backward direction. For that, you have to use not DQ but doubly linked list. Doubly linked list. Okay. The next one is to find the predecessor. It is required to traverse the list from the first node in case of singly linked list. Is it correct? Yes, this is absolutely correct. So answer is both 1 and 2. They both are true. There is no other option. Next is the advantage of dash is that they solve the problem if sequential storage representation, but disadvantage is that they are sequential list. They solve the problem of sequential storage representation, but they are sequential list. The answer is, of course, you got it right, linked list, because in terms of storage, it is logically anywhere. Any node can be anywhere, but in terms of traversal, you have to start from the first node and then you can move to the other node. Okay. What will be the value of top if there is a size of stack size is 5? If size is stack size 5, what will be the value of top? Can you tell me the answer? If assume it to be an array, this is 0, 1, 2, 3, 4, 5, say 6. What will be the value of top if there is size of stack size is 5? If stack size is 5, that means this is what we are talking about, 1, 2, 3, 4, 5. So it will be, top will be the subscript or index of the value. So it will be 4. Answer will be 4. Next is dash is not the operation that can be performed on Q. What cannot be performed on Q? Can you perform insertion? Can be performed on Q. Insertion can be from one side, deletion can be from other side, and retrieval can be done. You can go to any point and get retrieve. Traversal cannot be done. There is no traversal in Q, so answer will be D. Okay. There is an extra element at the head of the list, which is called as what? The extra element we have learned this in the previous discussion. It is sentinel. Sentinel is an extra element at the head of the list. Next is a graph is a collection of nodes called dash. Line segments called arc or dash that connect pair of nodes. So nodes are known as vertex or vertices, and the arcs are known as edges. Okay, vertices and edges. So answer will be A. Next is a dash is a graph that has weight of cost associated with edges. Is it weighted graph? Is it weighted graph or it is a network? Both are true. The answer is C. Both A and B. Next is, in general, the binary search method needs no more than dash comparison. Binary search methods, it will always have less than these number of comparisons. The answer is log base 2 n plus 1. Exactly. The first is which data structure allows deleting data elements from front and inserting at rear. Inserting at rear and deleting from front. Can you answer? These are 4 options for you. The answer is queues. Queues is a data structure which exactly does this only. Second is identify the data structure which allows deletion at both ends of the list but insertion only at one end. Deletions at both ends, insertion only at one end. These are 4 options for you. Can you answer? The answer is A. Input restricted DQ. Input restricted DQ. Now, which of the following data structure is non-linear? You know, data structure are of 2 types, linear and non-linear. Linear means you can only traverse sequentially and they're connected sequentially, while non-linear are you can go from one point or one node to another nodes also, means 2 nodes or multiple nodes. So, which of these is a non-linear? Can you answer? The answer is none of the above. All these strings, lists and stacks, they all are what? They are linear. So no, if the option would have been graph or tree, then you could have taken one of these. Now, which of the following data structure is linear type? String, list and queues, they all are linear type. So we'll go with the option D, all of the above. Next is to represent hierarchical relationship between elements. Which data structure is suitable? Is it DQ? Is it priority? Or G? Or all of the above? The answer would be tree, because this shows the hierarchical this type of relationship. Though they will be implemented either in the form of an array or a linked list only, but still the formation will be hierarchical. Then the next is a binary tree whose every node has either 0 or 2 children is called what? 0, here 0 or either 2. So is it a binary search tree or any other? Can you answer? This is the option for you. 0 or 2 children. Is it a complete binary tree or extended binary tree? We'll go with the extended binary tree, right? But complete binary tree also has this complete nodes, so either they have 2 or nil, but we'll go with extended binary tree. Next is the depth of a complete binary tree is given by depth. What is the depth? If you have a complete binary tree, you want to see the depth. Okay, so that will be, the answer would be, we'll take this option. Yes, the option is log n plus 1. We can easily find out like this, because in binary tree, this is 1 node, this is 2 node, see this is 4 node, so you will have 2 to the power n node. So you can easily take log and you'll find out the depth, but because the root is always there, so you add 1. Next is when representing any algebraic expression E which uses only binary operations in a 2 tree, then please read all these and try to answer. When representing an algebraic expression which uses only binary operations in 2 tree, the answer would be, which answer you are going to take? Let us see the first one. The variable in E will appear as external nodes and the operations in the internal nodes, and this is correct. The first one is the correct one. Next is a binary tree can easily be converted into 2 tree. Binary tree can be converted into 2 tree. How? The answer would be, let us go with the D. By replacing each empty subtree by a new external node, you can convert it. Next is when converting binary tree into extended binary tree. All the original nodes in binary tree are done what? You have to convert binary tree into extended binary tree. All the original nodes in binary tree are, the answer is the first one, internal nodes on extended tree. Okay. All the original nodes in binary tree are internal nodes on extended tree. Next is the post order traversal of a binary tree is this, DEBFCA. Find out the pre-order traversal. Now if you are aware of the traversal, there are 3 types of traversal: in order, pre-order and post order. This is the post order. This is what we have to find out is the pre-order, and the answer would be, the answer is C. Next is, which of the following sorting algorithm is of divide and conquer? Is it quicksort or any other? The answer is quicksort. Both quicksort and merge sort, they are divide and conquer algorithms. Next is an algorithm that calls itself directly or indirectly is known as, is it recursion or any other? Please try to find out. The algorithm that calls itself directly or indirectly is recursion only. The answer is B. Next is, in a binary tree, certain null entries are replaced by special pointers which point to nodes higher in the tree for efficiency. These special pointers are called what? Can you answer this? These special pointers, certain null entries are replaced by special pointers which point to nodes higher in the trees for efficiency, and these are threads. D. Next is, in the in-order traversal of a tree will yield a sorting list of element of tree in. You will get a sorted list if you perform the in-order traversal. In which tree? The answer is binary search tree. Binary search tree, you perform in order, you will get a sorted list. Next is in heap tree. Heap tree, you know what happens in heap. You always have the highest element and in the root, and for left subtree and right subtree also, these are heaps, that is highest element. All other elements are lower in the same case. What is the, in a heap tree, which is the true one? Can you guess the answer? The answer is D. Value in the node is greater than every value in children of it, as I suggested. Next is in a graph EUV, where U and V are what? U and V are what? The answer is endpoints of E. This is correct. Adjacent node. This is also correct. Neighbors. This is also correct. So all of the above. The answer is D. All of the above. Next is a connected graph T without any cycles is called what? Connected graph T without any cycles is it a tree graph? Is it a free tree? Is it a tree? The answer is, of course, all these are correct. All of the above is the answer. In a graph, if E is equal to U comma V means what? Please read these and try to answer. Let us see. U is adjacent to V, but V is not adjacent to U. This is wrong. E begins at U and ends at V. This is correct. U is processor, V is successor. This is also correct. So we'll go with the D one, both B and C. Next is if every node U in G is adjacent to every other node V in G, a graph is said to be what? The answer is, it is said to be. Now the next question is the memory address of first element of an array is called what? The memory address of the first element of array is the base address. We'll go with the base address. Next is the memory address of fifth element of an array can be calculated by formula. These are options for you. This is an array. You have to find out the 2, 3, 4, 5. This is the fifth element, X say. You have to find out the memory address of the fifth array. So base address, then base address of the array plus the width, that is it can be integer character, so we have to use the W width, and then what you have to do, 5, this is fifth, so 5 minus the lower bound. So the answer would be A. Well, W is this is exactly what I said. Location of array 5 is equal to base of array plus W into 5 minus lower bound. And W is the number of words per memory cells for the array. Next is which of the following data structure are index structures? Index structures. Can you answer this? The answer is linear arrays. These are index structures. Next is which of the following is not the required condition for binary search algorithm? So these are options for you. Please read them very carefully and try to answer. Which of the following is not the required condition for binary search algorithm? The answer is C. There must be a mechanism to delete or insert elements in list, not the required condition. Then because it has a condition that the list must be sorted, there should be the direct access to the middle element in any sublist. These are all the requirements, but this is not. Next is which of the following is not a limitation of binary search algorithm? Which of the following is not a limitation of binary search algorithm? The answer is, please read it very carefully. The answer is D. Binary search algorithm is not efficient when data elements are more than 1000. No. Must be sorted. Required a sorted array is the count of a sorted array is expensive and a lot of insertion deletions are needed. Of course, because it has to again balance itself to be a binary search tree. There must be a mechanism to access middle element directly. This is also a requirement. This is not limitation actually. Two-dimensional arrays are also called as, which is the answer? You know it. You know that they are matrix also, and in tabular form also. Matrix is nothing but a table only. So two-dimensional arrays are also called as. The answer is both of them. Now we come to the next question. Variable P is called pointer if. Variable P is called pointer if. See the answers, which is the correct answer. When a variable P is called pointer. P contains the address of an element in data. The A is the correct one. Next is which of the following data structure can't store the non-homogeneous data element? So this is a very obvious question. Arrays cannot store the non-homogeneous. It can only store the homogeneous, with same data type values or data elements. Next is which of the following data structures store the homogeneous data elements? Homogeneous. The answer, we'll go with arrays. We have already discussed this. We'll go with array, but records also, if you say that you have homogeneous data element, we can take this also, but we'll go with array. Next is each data item in a record may be a group item composed of sub-items. So those items which are indecomposable are called what? Each data item in a record may be in a group item composed of sub-items. So those items which are indecomposable are called what? So the answer would be The elementary atoms, yes, this is correct. Atoms, yes, scalars also. So we'll go with the D, all of the above. The difference between linear array and a record is what? Linear array and record. The answer is, let us see one by one. An array is suitable for homogeneous data, but the data items in a record may have different data type. This is correct. In a record, there may not be a natural ordering as opposed to the linear array. This is also correct. A record form a hierarchical structure, but a linear array does not. This is also correct. So we'll go with the last option, that is D, all of the above. Next is which of the following statement is false? Which of the following statement is false? Read them very carefully. You have to say or find out which of the following statement is false. The answer is, let us take one by one. Array are dense list and static data structure. Correct. Data elements in linked list need not to be stored in adjacent spaces memory. Also correct. Pointer stores the next data element of a list. No, pointer stores the address of the next node. Then linked lists are a collection of nodes that contain information part and the next pointer. This is also correct. So we'll go with the answer C. This is the false one. Binary search algorithm cannot be applied to which? BST. Oh, sorry, BSA. Binary search algorithm. The answer is sorted linked list. It cannot be applied to sorted linked list. Next is when new data are to be inserted into a data structure, but there is no available space. This situation is usually called as, is it overflow or any other? The answer is overflow, because the bucket is full, you want to pour some more water that will spill out. That is overflow. Next is the situation when a linked list start is equal to null list. That means what? The answer is, of course, the bucket is empty, you want to take out water. That means it is an underflow. Next is, which of the following is two-way list? Two-way list. Options are here for you. The answer is grounded header list. No, it is not a two-way list. Circular header list? No. Linked list with header and trailer nodes? No. So none of the above. None of the above is a two-way list. Which of the following name does not relate to stacks? Stacks. Is it FIFO list? First in, first out. Yes, it is first in, first out, because this goes with queues, not stacks. But LIFO, piles, push down lists, all are talked with reference to stacks only. The term push and pop is related to stack or any other. The answer is stacks. Next is a data structure where elements can be added or removed at either end but not in the middle. Is where? What is the answer? The answer is DQ. DQ is double-ended queue, we can say. Now you have in order traversing a tree, result in this. The pre-order traverse would return. I leave it as an exercise for you, but I'll tell you the answer. The answer is B. The first one is two main measures of efficiency of an algorithm. These are the options for you. The measure of efficiency is time and space. So we'll go with the third one, that is C1, time and space. So we have two complexity, time complexity and space complexity. The next is the time factor when determining the efficiency of algorithm is measured by what? So the answer would be, we try to find out the number of key operations. So D is the correct one, counting the number of key operations to measure the efficiency, time efficiency. Next is the space factor when determining the efficiency of algorithm is measured by. Now the answer would be, these are four options. Please read it very carefully and try to answer. The answer is first one, counting the maximum memory needed by the algorithm. So maximum memory is space factor, space complexity. The next is, which of the following case does not exist in complexity theory? We have best case, worst case, average case, but we don't have any null case. So this is the answer. We will not take the null case. Next is, the worst case occur in linear search algorithm when? What would be the answer? The answer is, in linear search, if the element is the last element, then we have to search all the way to find out the element. Okay. Also, when the element is not there, then also the linear search has to go all the way to the end and then declare that I could not find the element. So the answer would be D1. Item is the last element, or in the array, or there is not a single element at all in that array which is matching that element which needs to be searched. Next is the average case occur in linear search algorithm. When? So options are these. Let us read. When item is somewhere in the middle of the array, this is correct. We'll take this first one, A. When the item is in between, then we call it as an average case. Next is the complexity of average case for algorithm is what? The question, the solutions are here. You have to choose one of this. Let us start with the first one. The complexity of the average case of an algorithm is much more complicated to analyze than that of worst case. Yes, this is correct. We'll go with the first one only. Next one is the complexity of linear search algorithm is. What is the? Because we have seen that in this we have to search 1, 2, 3, 4, so n elements. So in the worst case also it will be order of n. So it will be, because this order is actually the worst case. If it would have been some omega or theta, we would have talked in different sense, but the worst case complexity is order of n. Then the complexity of binary search algorithm is what? Binary search algorithm. The answer is binary search algorithm. It is order of, we are searching, okay, we're not sorting, so it will be order of log n. Order of log n. Next is the complexity of bubble sort algorithm is. The complexity of bubble sort algorithm is. This is also an expensive algorithm, so it will be order of n square. N square. Next is the complexity of merge sort algorithm is. The complexity of merge sort, this is the best algorithm we have. So the merge sort algorithm, the complexity is order of n log n. The indirect change of the value of a variable, the indirect change of the values of a variable in one module by another module is called what? The answer is the side effect. This is side effect. Next is which of the following data structure is not linear data structure? Which of the following data structure is not a linear data structure? The answer is C. Array and link list. They both are linear data structure. Non-linear means graph and tree. Okay, so the answer will be none of the above. This one. Next is which of the following data structure is linear data structure? Arrays. It is a linear data structure because graphs and trees, they are non-linear. So we'll go with the array. C is the answer. Next is the operation of processing each element in the list is known as the operation of processing. And this is nothing but the traversal. Next is finding the location of the element with a given value is. And the location of the element with a given value is, the answer is searching. Next is arrays are best data structures. Arrays are best data structures. Options are here. The answer would be A, for relatively permanent collection of data. Next is linked lists are best suited. Options are here, best suited. Let us see these B1. For the size of the structure and the data in the structure, these are constantly changing. Linked lists are best for this. So we'll go with the B1. Next is each array declaration need not give implicitly or explicitly the information about. The answer is each array declaration need not give implicitly or explicitly the information about. Let us see the C1. The first data from the set to be stored. So answer is C. 20. The elements of an array are stored successively in memory cells because. Why? The answer is the first one. Let us see the first one. By the way, the computer can keep track only the address of the first element and the address of the other elements can be calculated. So this is very good. We'll take A. Okay. Next is which of one of the following permutations can be obtained the output using stack, assuming that the input is the sequence 1, 2, 3, 4, 5 in that order. Which of these permutations can be obtained the output using stack? So the answer would be, the answer is, can you give the answer? The answer is 3, 4, 5, 2, 1. This is the answer. So these are the permutations that can be obtained as the output using stack, assuming that the input is this sequence 1, 2, 3, 4, 5 in that order. Okay. So these are the permutations I'm saying. I'm just saying that if we are placing the data in that order 1, 2, 3, 4, 5. So in this stack we can only take value like 5, 4, 3, 2, 1. Okay. But we are talking about the question is somewhat different. Next is the initial configuration of a queue is ABCD. A is the front. So this is ABCD. A, B, C and D. So the initial configuration is like this. To get the configuration DCBA, one needs a maximum of, we want what? DCBA. Let us take like this. DCBA. So for that, what we have to do is, we have to do 3 deletions, and then we have to insert CBA here. So the answer can be 3 deletions and 3 additions. 3 deletions here, and then adding these 3 here. Linked lists are not suitable data structure for of which one of the following problems. Linked list not suitable for what? Insertion, binary, radix, and polynomial manipulation. The answer is binary search. This is often a question asked, that can you use the binary search for linked list? But binary search cannot be applied. This is not a suitable. The overhead should be great, and of course you need data to be sorted, and that will be taking another time. The number of possible ordered trees with 3 nodes ABC is number of possible ordered trees with 3 nodes ABC. So what can be the answer? The answer is 12. Number of possible ordered trees with 3 nodes. This is 12. Next is, which of the following? I hope that you are going to solve it. Which of the following algorithm design technique is used in the quick sort? Is it divide and conquer or any other? The answer is divide and conquer. C. The number of swapping needed to sort numbers this in ascending order using bubble sort is how many? So are we going to solve it? Let us see. First of all, the answer, let me tell you the answer. The answer is 14. So it is not possible for me to tell you these 14 swapping. I'll tell you one of this. Okay. The number of swapping needed to sort numbers. How are you going to do this? First of all, we will try to match 8 and 12, 8 and 22. Which one is the greater? Okay, which one is the greatest? So because 22 is already greater than 8, will not swap. We'll try to check for these two. Which one is greater? We have 8 here. Which one is greater? 22 is greater, so we will swap this. So it will be 7 and 22. Then what? Now 22 is here. We'll search, or we'll check for 22 and 9. Which one is greater? 22. So 9 will be here, and 22 will go here. Okay. So we have 22 will take 9 place. Now which one is greater? 22 and 31. 31 is greater. So we'll not swap anything. We'll check for 31 and 19. Which one is greater? 31. So 19 will be swapped with 31. 31 and 5. Which one is greater? 31. So we'll take 5 here. Now 31 and 13. Which one is greater? 31. 31 will come here, and 30 will be here. So this number of the exchange we have done, might have computed it by now. So this is one pass. So the number of swapping needed to sort in ascending order. This is just one pass. Okay, and we have computed, we have taken certain swaps. So you just try it by yourself. The answer will be 40. This way we'll get the bubble sort. Which one of the following statement is true? Let us see which one of these is true. Can you answer this? The answer is A. Optimal binary search tree construction can be performed efficiently using the dynamic programming. Optimal binary search tree construction can be performed efficiently using the dynamic programming. Next is, given 2 sorted lists of size M and N respectively. 2 sorted lists M and N. The number of comparison needed in the worst case by the merge sort will be what? Can you answer this? 2 sorted lists, you need to merge them. Number of comparison needed in worst case to merge these. The answer would be, see, this is M, this is N, so the answer would be M plus N minus 1. Merge sort uses what? Is it divide and conquer or any other, like quick sort? The answer is again A1, because quick sort and merge sort, they both follow this strategy, divide and conquer. Next is, the following sequence of operation is performed on stack: push 1, push 2, pop, all these. The sequence of popped out values are popped out values. So let us see. We push 1, so 1 is here. We push 2, 2 is here. We pop, so 2 will come here. Then we push 1. Then we push 2. Then we pop, pop. So it will be 2, 1. Okay. Then again a pop, so 1. Then push 2, and then pop. So what will be the answer? The answer will be 2, 2, 2, 2, 1, 1, 2. This is the answer. A. Which of the following algorithm design technique is used in the quick sort algorithm? And we have just known this, divide and conquer. Which of the following is useful in traversing a given graph by BFS? BFS. The answer is Q. For BFS, we use Q. Belt first search. Which of the following is useful in implementing quick sort? Quick sort. The options are here. The answer is stack. For quick sort, we use stack. An IP address is a numeric quantity that identifies what? This is out of the box question, but we have taken two of these. The IP address is a numeric quantity that identifies. The answer is A. Network adapter to other devices on the network. Next is you can make telephone calls over the internet using technology called VoIP or any other. The answer is VoIP, Voice over IP Internet Protocol. What is the result of the following operation? Push SX, stack, now you're putting X on it, top. What you will get? The answer will be X. Because you have pushed X, so top will be pointing X, now you're taking top of this, so that will be X only. Next is Q can be used to implement what? Q. The answer we have just seen a similar question. Answer is quicksort. Q can be used to implement quicksort. The number of binary trees with 3 nodes, which when traversed in post order gives the sequence ABC, is the number of binary trees with 3 nodes. The answer is 5. I hope that you are going to do it by yourself. Sparse matrices have sparse matrices. They have many zeros. B. The postfix expression for this is Let me give you the answer and just try it by yourself. The answer is A. This one is the postfix expression. The vertex of degree 1 is called. It is pedant. So these were the MCQ questions on your data structure and algorithm. Thank you so much. Take care.